All right, welcome everyone. So this is the ZCon 6 panel about proof of stake. So I'm really excited to have everyone here. So we have some Zcashers and then some developers of other proof of stake systems that we highly regard participating here. So I'm pretty excited. So we have Christopher Goes, who's at the Enoma Foundation, Daira-Emma, who's one of the key Zcash protocol developers, Henry de Valence, who is working on Penumbra and also worked on Zcash in the past at the foundation, Vitalik Buterin, who's at the Ethereum Foundation, and then Zuko at Shielded Labs. And I'm Nate, I'm also at Shielded Labs. Let's see, so for some context, Zcash is based on the Bitcoin design originally, but we are working to transition it to proof of stake. And so we wanted to get other builders who have familiarity and experience with proof of stake into a conversation to see what we can learn from each other. Yeah, so I mean, I guess the first thing that's on my mind is in our transition, we are trying to decide the tokenomics issues for Zcash. And we were wondering if anyone has advice about how to do that. The main constraint that we have is that we want the issuance to follow the Bitcoin schedule. And I'm not quite sure how that might impact like security or participation. So I'm curious if anyone has advice on that. How about you, Christopher? Anything?
Well, I think of the projects represented here, the one which has been running a proof of stake system for the longest is Ethereum by far. So maybe that's the most useful example, at least if you want a long history of data. I can say that in my experience with Cosmos chains, at least initially, I think I was overly worried about a very strict economic understanding of security, both in the sense of security from slashing, but also in the sense of paying validators enough to participate. And in fact, at least in many Cosmos chains, such as Namada and perhaps Penumbra, although I don't know the economics there as well, many validators participate for a complex set of reasons, which include, but are definitely not limited to, exactly what they get paid. And many validators make decisions about how to operate for a complex set of reasons, which include, but are not limited to, what and how much and for how much they might potentially get slashed. So I think, an asset that the Zcash community has to draw on is a set of potential validators in the kind of broader community. They're running a validator is reasonably accessible compared to doing other things like developing Zcash that is potentially less accessible. And perhaps a way to figure this out more concretely would be to chat with some potential validators and see what their cost structures look like. Another note is that validators often, at least in Cosmos networks, benefited in ways that weren't just direct protocol issuance, like maybe they got some reputation, they were able to launch other services and charge for those. Some validators ended up investing in other projects. These may or may not apply to Zcash's case, but my point would just be that looking at this question holistically can perhaps relax some design constraints that look kind of strict and maybe with supply cap potentially problematic when you're just looking at it from a strict, rational actor, what do I get paid to run my server sort of perspective.
Yeah, that makes a lot of sense. I'm curious to hear from Dara.
Yeah, that raises an issue that maybe we can talk about it more later. The extent to which slashing should be relied on relative to enforcing consensus rules. Because if you can enforce something that you would have slashed for, then why would you need the slashing?
Yeah, I'm really curious about slashing also, especially if there's users delegating stake, which might be a really popular thing to do. It seems like it is empirically, but I assume many users don't understand if there's slashing, like what those risks are.
Yeah, who is responsible for that? Do the users that are delegating, do they have to sign an agreement that if the validator is slashed, they lose some portion of it? I don't know.
Some
That
validators
is
in
how
Cosmos.
staking pools work so far.
Yeah, if you delegate to like Chorus One using their website, they make you sign an EULA or not EULA, but some kind of agreement. What legal force that has in court, I mean, who knows? But it does seem to be a practical concern as well as a theoretical one.
Yeah. I'm not too up to date on the state of slashing because I had heard at one point that it's relatively rare, and that maybe many protocols don't even employ it. Um, I'm curious which protocols do, and if anyone has like experience with it being exercised, and what they learned from that.
So for Penumbra, we do have a shielded proof of stake system that is live, and there's some lessons there. But we tried to not innovate too much and keep it as close to the Cosmos design as possible. To go all the way back to the original question of like what are some key insights. One that I would raise that we could talk about is like I don't think there's any real tension between having a proof of stake mechanism and having a particular issuance schedule. If you've decided on a particular issuance schedule, you can distribute that issuance through the staking mechanism rather than through mining. And all of the problems that you might have about like maybe there's not enough issuance, you already had by the mining. It's just that now actually there's probably a fairer access to that issuance. Like right now, Zcash holders can't really access any of the mining reward. And in the past that, has some benefits, but I think at the moment, there's also a benefit to the access. On the specific point about slashing, and to Dara's question about why slash for stuff that you could otherwise enforce. In Penumbra, there are two conditions that result in a validator being slashed. One is equivocation. So if they double sign a block at the same height, they are that's misbehavior at the consensus protocol level, and they are slashed for equivocation, and they're permanently removed from the validator set. So if that validator operator wanted to run a validator again, they have to like make a new identity key. They have to get everybody to redelegate to them. It's like that's the game over for your validator, because the one thing that you must never do is double sign a block. Like that's literally like you have one job. And the other kind of slashing that we have is downtime slashing. So if a validator misses too many blocks, then it is slashed for non-participation. But that slashing penalty is very, very minor. I believe I don't recall the exact parameter off the top of my head, but I think it's something like 1 basis point or something. So it's literally just kind of a slap on the wrist. It's like, you should actually try to participate in consensus. But having that mechanism is important for protecting liveness, where if a bunch of validators are starting to kind of flake out and go offline or whatever, that it's a way to basically kick them out of the consensus process and allow other validators to take their spot.
Yeah, I've always thought that the Penumbra team had good technical taste. Those are exactly the reasons why I would keep slashing for some things that you can't enforce the consensus line.
Yeah, so let's see, that brings up a few things for me. One is, so it doesn't seem really feasible to distinguish between like stake that belongs to the operator versus stake that's been delegated. Although the protocol can help make that easier and safer. So does that imply slashing always slashes all delegators, and is that a
Yes.
problem? Or a tangential question is, it feels like the security is predicated on participants not wanting to be slashed, but I can't think of a way that ensures operators are financially incentive aligned. So it could be like the operator is actually just like a cloud service provider, providing a service on behalf of someone else who is providing the reputation and acquiring stake. That seems like a pretty deep agency issue. Is there anything we can learn from that, or is that concerning to anyone else? Let's hear from Vitalik.
Yeah, I mean, I think the way I think about it is that what we want is we want a hard guarantee that says if the chain breaks in a particular way, then someone somewhere loses $100 million, or ideally like an amount that gets bigger the bigger the chain is. And like that to me, like having that hard dollar guarantee is nice because like it's just a hard proof that like there are no like weird sneaky ways around it. Like if you're going to break the chain, it's going to be expensive, and like that does mean that like if there is going to be that loss, then it has to be allocated to someone, right? And like I see this as like an important thing that's complementary to things like the 2/3 rule, right? It's like the 2/3 rule is sort of the thing that protects the chain in peacetime, and every time the chain breaks, someone loses $100 million rule is like sort of what protects it in wartime, right? It's like when you can't count on the 2/3 assumption to be met because possibly like literally half the chain is 2 actors, then like you want to have this other rule as a fallback. And then the question is, well, if you have that loss, then who do you allocate it to, right? And like to me, slashing delegators is fine, right? Because as a delegator, it's your responsibility to choose good actors to delegate to as opposed to non-good actors. And I mean, like it is a thing that I think can be made to be very low risk, right? Like even if you look within Ethereum economics, there's a lot of these mechanisms that say, like basically the penalty is only like non-negligible if you're like you or whoever you delegated to like breaks at the same time as a lot of other actors break. And so if you just like randomly make a mistake, then I mean by definition mistakes are going to be uncorrelated, so it's almost certainly going to be fine for you. So that's like how I see it. Yeah, there's 2 things and how they play together.
Zuko, I see a hand up and you're looking thoughtful.
Yeah, so I've been thinking a lot about user interface. Is there a button in your wallet that says stake? And then the first thing I get stuck on is how does the user know what the risk is if they stake? Like, is there a little icon they can tap to pop up something that says, here's your risk? It's not an EULA like the Course One website, but are they assuming it's riskless? Like a 0% chance that they'll lose anything? Is there a bound on how much they could lose? Like you could lose 100% of what you've delegated, or you could lose 10% of what you've delegated. So that's what I'm stuck on in terms of user interface. But I want to rewind to what you folks said about slashing. I really liked what Daira-Emma said. This like changed my view of things, which is don't punish what you can instead prevent, right? And so Ethereum switched from pure proof of work to proof of stake. Penumbra launched pure proof of stake. Namada is launching, like it's already launched, except you can't make transactions, right? In pure proof of stake.
You just can't transfer NAM. You could do all the other stuff.
Oh, okay. Awesome. But what we're talking about is this Crosslink protocol that Daira-Emma with Nate's help previously came up with, in which there's still proof of work and proof of stake. And the proof of stake side doesn't validate transactions and it doesn't do anything for liveness. It only serves for finality. So my question is, in Crosslink, what damage could you do to users if you like had 2/3 of the stake? Can we prevent it, or is it so limited?
Not very much in practice. That actually feeds into another thing I was going to ask about. But first, the technical question. So the things that you would need to slash in the proof of stake component of Crosslink are the same things that you slash for in Penumbra. You slash for those things also in Ethereum, but I don't know whether Ethereum slashes for anything else. And the reasons are the same, because those are the things that you can't enforce in the consensus protocol, because they're the things that the consensus in the strict sense depends on. So now in the specific case of Crosslink, the construction is that if either the proof of stake side or the proof of work side is secure, then the whole protocol is secure, and that is made more precise in the documentation. Although I haven't written up the security proof yet. But assuming that's correct, the only remaining caveat is that so the amount of money you have from issuance is split between the validators and the miners. So this has always been sort of one of the issues I've been concerned about with this approach. I still think it's a good approach, but we need to make sure that the incentivization is there on both sides, because if you split it and it turns out that neither's enough, then the theoretical guarantees of the protocol are not being met. So how much is enough to incentivize miners and validators in concrete terms?
But to be clear, your answer to my question is that even in Crosslink, you need to slash for equivocation because you can't prevent it and it could do harm.
Correct. Yes, because if you don't do the same things to mitigate failures in the proof of stake protocol, then you might as well not have a proof of stake protocol. You have to sort of put in as much effort as you can on each side in order for the whole idea of security that's based on the security of either to work. Otherwise, it's just risk compensation.
Yeah. Vitalik, do you have your hand up?
Yeah. So just getting back onto this topic of like why you should not punish if you can prevent. I mean, I definitely fully agree with this principle. And I mean, I think this has also, for example, been a really key reason why I've been like so enthusiastic about ZK rollups and ZK plasma and Validiums in particular. Relative to their optimistic cousins, right? It's like it's just such a much cleaner security model. And then, I mean, even on the Ethereum data availability front, right? If you remember, the 2017 era constructions depended on fraud proofs, and like as soon as we discovered that with KZG you could do everything built in, well, that we just immediately switched to that. With staking, of course, the challenge is that there are two behaviors that, like, at least with current technology, we cannot prevent. And one is censorship, and the other is equivocation, right? And like there is a very long-term future where if you have like widely distributed quantum computers, then like you could maybe do magic with one-shot signatures. Though, interestingly enough, like even that doesn't solve the censorship case. And like this is also one of my realizations, right? Is that I think a lot of people kind of lean too hard on thinking about the equivocation case, because actually the equivocation case is easier. The harder one is the censorship case, right? And so, like in the Ethereum case, for example, like basically the way that you would resolve that is like you can't do it fully yet in protocol. Like there is at some point a subjective judgment of like is a particular instance of blocks being reverted bad enough that you do a minority fork over it, right? And then you do a minority fork, and then like the majority, that was censoring, end up getting their deposits in activity leaked, and they lose half their money, right? So, and then that one, like the challenge is that if it was just equivocation, you could also say things like, oh, well, one benefit of delegation and sort of passing through economic like penalties to delegators is that it encourages them to explore like second layer constructions to try to like actively prevent the slash equivocation. So like trusted execution environments in particular, right? Because like that stuff is way too brittle for layer one to commit to, but at like application layer, you're able to have different users use different ones rapidly, iterate, switch between them, and so on. But obviously for censorship, like that particular solution doesn't work, right? And it's like actually an interesting and more challenging problem to ask, like what does, and like it feels like the solution involves non-zero like social consensus of some kind, right? But I think you want to make at least the process of like losing like or getting to a point where you move from consensus on the formally winning chain to a point of like, well, there's actually something to decide, like as automated as possible.
Yeah, on the point of delegation and how much risk delegators are taking. I mean, if delegators are completely sort of disconnected and not paying attention to what the validator is doing, then why are we allowing them to stake their money? From a consensus protocol point of view, that doesn't make sense, even if there might be secondary benefits to their participation.
So that's a thing that I think comes back to a point that Vitalik made earlier about having a kind of hard guarantee of like how much loss there will be somewhere, is a really good way to look at this. And I think a key insight, which is true for all blockchains, but is especially true for Zcash and other shielded chains, is that the protocol cannot understand beneficial ownership. It's just outside of the concept, like the universe of concepts that it can deal with. And this principal agent problem that could occur with like delegators or validator operators actually is also going to occur in all kinds of other ways, right? Like maybe the validator operator has like maybe they're leasing cloud servers and the cloud operator is malicious, or maybe they have, their own dedicated hardware, but it's in a data center, but somebody can access the data center. There's all like there's this like fractal principal agent issue all throughout the stack. And the way to solve that is not to try to have the protocol take into account each and every possible different failure mode. Rather, it's to have the protocol say, there is going to be this much economic loss. And now as like users or stakeholders of the protocol, like go figure it out. Go figure out like how that loss is going to be apportioned, and sort of trust that the incentive created by the threat of that loss will propagate through the entire system design. And I think that at a fundamental level, like there's no way that you can do better than that. So you should take that as a given and then just try to design it into the system. And this is a reason why I think it's actually important to have delegation built in as a kind of first party part of the protocol, because otherwise like that need or that market desire to have delegation is not going to go away. And it's likely that some system that someone would build on top is actually probably going to be worse, or will introduce new kinds of systemic risk that as a protocol designer you could have like handled better.
Yeah, I mean, I'm kind of disappointed that we didn't pay more attention to mining delegation when we launched, because as it is at the moment, you're just delegating to a mining pool, and the way people sort of model the control of the hash rate is they look at sort of total mining pool shares, which they should, because that's a single point of failure. The fact that there are thousands of individual miners contributing to a pool's hash rate doesn't matter. It's the total pool share that matters. Whereas if we'd kind of, I guess we didn't have time, so so much else to do. But I really did want us to look more closely at delegation protocols that would give the individual miners some kind of hold over the pool, so that the pool couldn't just do whatever it wanted.
Christopher.
Yeah, I mean, relevant to that point of delegators making decisions, I think a pertinent question for Zcash to think about in this context is, how you want those decisions to be made, or what kinds of social, in some sense, this is a miniature, case-specific web of trust that delegators are using to make decisions about who to delegate to. And parts of that web of trust can live in the protocol, parts of it can live outside of the protocol. In the sort of standard basic proof of stake designs, delegators are making individual decisions, as in they're individually picking validators. Maybe they pick multiple validators. They're assessing them individually. In the kind of surrounding social infrastructure that tends to emerge on top, and maybe in Ethereum, this could take the form more of market infrastructure like liquid staking tokens and other things. In other ecosystems, it might take the form of recommendations. In theory, someone could develop insurance products. I don't know. I think that exists in Ethereum, but I don't know of it in Cosmos. But not only the question, I mean, one, you could consider other just delegators making individual decisions about who to delegate to, at least in my opinion, is not like the be-all, end-all optimal equilibrium. Like, I think some amount of intermediation where you have more principles in between, at first glance that looks bad, but at second glance, the thing which that gives you is that now there are parties that have more time to assess the validators, and they can split the cost of that time amongst the parties that delegate to them. And I think you see this in, to some extent in liquid staking tokens like Lido. And, I don't have an opinion on Lido from a network security perspective, but I do think that they probably have more ability to commit capital and time to evaluating validators and validator security than many individual delegators would, right? So there's some pretty complex trade-offs. And the social infrastructure of, what does the user see in the wallet? How do they get that information? What order is the list of validators put in? Like, some of these things sound kind of dumb, but actually they're really important. And one thing I think a bunch of Cosmos chains got wrong, which Zcash can learn from, is that they rank the validators by voting power. And delegation is really sticky. So as soon as a bunch of delegators started delegating to, some initial validators, those initial validators were ranked first in the interfaces, they were ranked first in the block explorers, and most delegators, without the ability to assess in detail each validator's security setup and other network contributions, etc., they just picked big ones because those seemed safe, right? And
Yeah,
this is dangerous.
The same phenomenon occurs in mining pools. People tend to pick the biggest mining pools because they think that's the more stable. So just to clarify, when I said that I regretted that we hadn't spent more time on delegation protocols, I don't necessarily mean consensus protocols, that the consensus part of this should be minimized to just the necessary mechanism. I'm actually interested in how Penumbra does this. Maybe I should have looked at the docs beforehand, but what is necessary in the consensus protocol, Henry?
So for Penumbra, we took Tendermint off the shelf, such as it is. And the thing to understand there is like what Tendermint cares about at the consensus level is just like a weight, a set of keys that are the current active participants in the consensus set, as well as a set of weights of how much voting power each of those keys has. And in the interface between Tendermint, which is the generic BFT replication engine, and the application, which is the state that's getting replicated. So if Zcash were to do this, it would be like, okay, all this shielded pool state and everything is in the kind of Zcash app, and then there would be this consensus engine. In that interface between those two parts, the application can send to the consensus engine an update at the end of a block that says, here are some new validators, and here are new weights for the validators. And if you set a weight to 0, it gets dropped out. And so the actual consensus layer is not at all concerned with any of the details about how the staking is happening or whatever. In fact, the engine is just as happy to do a kind of proof of authority chain where those keys and weights are kind of static and fixed for all time. The staking system is the part of the application that links the kind of economic security arguments with the consensus security properties. And all the rest of the application is like, sort of relatively unimportant for the consensus security, but the staking part is the part of the application that has to be co-designed with the rest of the system. So for Penumbra, the way that we modeled this, because we didn't want to have this tension of like, as a holder and as a stakeholder, like, do I get to have privacy or do I get to participate in staking? That seemed bad. We wanted the staking to be done inside of the shielded pool. And in order to avoid having to pay out staking rewards to unknown participants, we created this concept of delegation tokens, which are effectively shares of a validator's delegation pool. And so that's what the application is tracking. When people do a delegation, they're kind of getting these delegation tokens, and the supply of each validator's delegation token is giving their voting power. So all that is tracked by the application, and then it sends updates to Tendermint, we self-impose to only do it at so-called epoch boundaries. But to Tendermint, it just looks like, hey, some new weights are coming in. And crucially, to any other system that's looking at Penumbra, they don't have to know any details of how the Penumbra staking part works. They can run a Tendermint-like client and just see like, okay, this is the sequence of block headers, and I can verify that. And that allows Penumbra to do interop to other chains without those other chains having to be aware of like, hey, this is our weirdo custom staking thing.
Yeah. Yeah, that's coming back to me now. I have read the docs. I just needed to load back into my brain. That was a great explanation. That actually brings up another thing, which is that the kind of split between what I call the L0 and the L1 in Zcash is very messy. So I think that the L0,
sorry,
so
Oh,
I can explain. No, I was going to explain. So L0 is sort of the consensus protocol in the kind of distributed systems literature sense. So just agreeing on an eventually consistent chain of blocks, basically. And the point of that is to agree on a total ordering of transactions. So if you can do that, and if you can separate that from all of the rules that are about the economic computation that you're trying to achieve, that's incredibly useful. It sort of clarifies the analysis. It makes it easier to respond to security flaws. It's just so much nicer. It makes the code nicer. Whereas in Bitcoin, although I'm not going to place all the blame on Bitcoin here, because we also made this kind of mistake as well. In Bitcoin, they're just completely entangled. And Zcash inherited that from the transparent part and failed to learn how bad it was for the shielded part. So if we can improve that when we move to proof of stake, I would like to. I think maybe the Crosslink design is not the does not lend itself completely to that, because it's still basically a proof of stake chain with a finality gadget on top, especially Crosslink 2. So Crosslink 1 was more complicated. It was based on this Snap and Chat paper. And I basically ripped all of that out because that had a lot of problems and complexity. And Crosslink 2 is just, you have a proof of stake chain and you have a method of determining where what is final. And yeah, that means that the entanglement between L0 and L1 is still in place for the proof of stake chain. It has to be.
Sorry, can you say again? Okay, but you want to disentangle what?
So L0 and L1. Okay. L0 is agreeing on a totally ordered sequence of transactions, which must be eventually consistent, and it must have assured finality. In other words, so there is a prefix of the chain that you can be as confident as possible does not roll back for any node past that point. So all nodes agree on that. And then L1 is everything else. Well, okay. L1 is all of the other consensus rules in the sort of looser Bitcoin sense. It's the sort of how the shielded protocol works, sort of the idea of UTXOs, so the idea of notes, sort of all of the details of the zero knowledge proofs and the signature schemes and all of the cryptography and well, the cryptography that is not necessary for L0. So some cryptography is necessary for L0, but that should be cleanly separated, and it just isn't at the moment.
So I wanted to jump in because there's a user question, and I think it's helpful to connect these really quick, because the question is, why are we Zcash developers interested in deploying Crosslink? And the question says, instead of doing it the way Ethereum, Penumbra, or Anoma are doing it. And I think, like, reading into the question more, if I set aside Ethereum, there's something really appealing about just launching a new system with a new design. But Ethereum made a transition from proof of work. And so our rationale is that we need to make a similar transition. And there's sort of two choices. One is to do it in steps to get to the goal that are more conservative and sort of bring everyone along safely. Or another approach is to have kind of a flag day where we switch over to a new protocol, a consensus protocol, kind of at once. And so far, I mean, I think most of us lean towards that seeming too risky. And so we're taking the approach that's roughly similar to what Ethereum did, in fact.
I mean, I think of them. I think of them as three separate approaches, because so what Ethereum did and what Zcash is proposing to do are both very conservative. So you can sort of you can so Ethereum did it by having lots of stages and being very, very careful at each stage. It's incredibly impressive, actually. I think the amount of care and the engineering and the diligence and the professionalism with which the various mergers were handled are exceptional. Hats off to Vitalik and the rest of the Ethereum community. I'm just going to a round of applause for how they did that. And they made sure that it was safe. It's a huge amount of work, and it took a long time.
Mm-hmm. So I remember the merge was so amazing for me and other like protocol people because nothing happened. But that's why it was so good.
That's what you want in a network upgrade. I don't know. Maybe sort of Vitalik can sort of describe his perspective on that. But so we're taking a different approach that could get to having assured finality sooner, but that kind of does less because we still have the proof of stake chain so underlying it. Now that doesn't mean that we couldn't so do another. Right. Sorry, did I say we still have the proof of work chain underlying? Did I say proof of stake? I meant proof of work. That doesn't mean that we couldn't make another change after that. So once we have assured finality, once we have sort of a validator ecosystem, then one option is then to do the flag day, where we basically rip up the proof of work chain, because the validator ecosystem is working well enough that we can just use that protocol. I'm really oversimplifying there.
Yeah, definitely a possibility. I wanted to hear from Henry because I was curious.
Yeah. So I originally raised my hand for this question, and I would say that like actually it would be possible for Zcash to just do this kind of like straight shot transition to a proof of stake system and go and design the whole, like, you know, how the proof of staking, how the staking system is going to work with the rest of Zcash, and get all the code working, and then like have a day where we all agree to like turn off the old chain and then like turn on the new software. And I think that the chance of that working is like at least 70%, right? Like it would
Exactly.
probably work, but it probably
Exactly.
is not good enough, right?
You
And
think we can
the difference,
all agree?
yeah, the difference I
I would
think with
I would
like,
even say 75%. So our estimates are very
yeah,
similar.
the difference with like with something like Penumbra, where we didn't have a system already, and we went through I think like 80 different test nets. It was hilarious. It was a sequence of disasters. We learned a lot. But because it's a new system, like at the point that you're kind of getting the whole community to start running the software for mainnet, quote, for real, like it's still like a little bit not for real, right? And for the Penumbra launch, there was this kind of like phased process where many of the features of the chain, in particular, like the interop with other chains or the DEX or whatever, were kind of like disabled by parameters. If it had turned out that the whole thing had been like there was some fatal like problem where it just like didn't work at all, like I think not likely, but like had that happened, the consequence is fairly low because you're still building the shelling point around the system. But for something like Zcash or Ethereum, where it already exists, you can't really do that. And so I think that the phased approach is definitely the way to go. But what I would say is, and this, I don't want to backseat drive too much, but I think that the effort should focus on like, okay, there will be a future where we're just running proof of stake. And like Crosslink is a kind of means to an end to getting to this future where we have proof of stake. And so we should focus on the kind of eventual outcome of there's just the proof of stake part, and not overbuild the kind of transitionary scaffolding.
Yeah, Zuko.
That's really interesting. I have almost the opposite hypothesis, and that approach is how Daira-Emma and Nate originally conceived of Crosslink. But I have a hypothesis which we don't need to resolve now because we can resolve it in like 2 years with a whole bunch more experience and hopefully probably better science too. But my hypothesis is combo proof of stake and proof of work is better than pure proof of stake, and we won't want to switch when the time comes. So I'm going to throw that out as an alternate worldview.
So I have a strong opinion on this, which is I want to get rid of the energy usage of proof of work, because I really care about that, because kind of doing that, if you compare the energy usage of the proof of work in the Zcash network to any of our individual energy usage, there's no comparison. That it is pointless for me to kind of insulate my loft or whatever if I can move Zcash to pure proof of stake, because that's it is such a significant reduction in energy usage, and I personally think that we're in the throes of a climate catastrophe.
So we've touched on so many things that I want to dig into more, but one of them ties into the relative merits of hybrid protocols versus pure BFT protocols. So one thing about BFT protocols that makes me anxious is if they halt, which is possible. I'm not too clear on how they restart, and I'm anxious that the way they restart in practice is there's just kind of a cabal of operators in a Discord channel who know each other and they define the Schelling point. And the reason that makes me nervous is it seems like a kind of centralized control that could be captured. And so I'm wondering how everyone here thinks about that problem, or what solutions you're imagining for that. Vitalik?
Yeah, I mean, I would recommend just adopting Ethereum's like hybrid finality and availability and available chain mechanism and the inactivity leak mechanism for recovery. It's a thing. It's been running for a while. There's now even an unintended live fire drill of the recovery part happening on a test net right now. So you know, a lot of good information about how all the different parts of it work, and within the if the like, proof of stake redesign effort that Justin's been calling the beam chain. So far, there's a lot of optimizations that have been thought about, like basically around like 3 slot finality and effectively like removing some of the complexities of Ethereum's proof of stake and basically making it feel pretty similar to sort of like what Tendermint plus available chain might end up looking like. So I think it's not that bad to just like borrow it or even collaborate with Ethereum researchers on, you know, like making sure the details are what we need.
That intrigues me, especially because so once we move to this crosslink step, which I think we've been discussing, is likely just to be a first step before future improvements. Once we move there, we will have a hybrid with a dynamically available subprotocol, which is proof of work, but Ethereum has a dynamically available protocol that is not proof of work. And I'm curious if you could share more about the mechanism, I forgot what you call it, but to ensure availability. And one question I have is it something that helps ensure that the chain never halts, or is it something that can, like, if the chain does halt, is that just not
Yeah, right.
a consideration for this protocol?
Okay, so basically, yeah, you can think of the mechanism as being a fork choice rule, and so there is a chain, and the chain follows a fork choice rule, and then separately from that, there is a finality rule, which basically reinterprets messages that have been published and like shows like enough people have made messages here that like provably like they cannot go back on this block without a third of them getting slashed, right? And then when that happens, the block is called finalized. And obviously, there's many different types of fork choice, right? So like the types that existed back in 2013, 2014, like Peercoin, NXT, and all of those ones, they basically just had like one validator per block. And you could literally run a finality gadget on top of that, right? Like you could say one staker per block, you have some number of them, and then like you just run FFG to finalize over that. And like finality will probably take a day, but like that's a simple one. What Ethereum uses today is like basically like goes even further in the direction of where the proof of stake chains ended up going, which is they say, well, instead of during each slot choosing one block or one staker to send a message, you choose like some committee of them. And then like you have a fork choice rule that takes into account all of those votes. And then the reason why you want to do this is so that even if you have a malicious staker selected for one block or even like quite a number of blocks in a row, the committee like keeps them in check. And if that committee is large enough, then like they can't actually do anything except for, I mean, obviously like censor transactions from the block that they create, right? Or just disappear for that amount of time entirely. And so in like one of the ideas for like the end game of this is basically, yeah, like if you make the fork choice rule be LMD ghost, which basically says like from a parent you choose the and if a parent has multiple children, you choose the child based on which child is supported by more of the latest votes of all of the stakers, then like potentially, yeah, which is what Ethereum does right now. But what you could do is if you get rid of committees, then like you basically have a mechanism where like everyone is voting in every slot. And then you layer the finality rule on top of that, and then you have like basically near like optimal or like near optimal finalization time. And yeah, so like the mental model is basically that like you think of the base as being this available chain, and the available chain keeps running. Like even if World War III happens, then like 90% of stakers go off, the other 10% keep it going. And then of course, if internet gets cut off, then you might have like 10% keeping it going in the US and 5% keeping it going in Europe. But that's like an unavoidable trade-off of any of these systems, right? And then on top of this, you have finality, and then you have the inactivity leak thing, so that if like a huge percent permanently go offline, the chain eventually recovers to finalizing with the remaining group.
Yeah,
Oh, I
I
see.
think
So
actually,
just
sorry.
a clarification, the inactivity leak, it only applies to finalization, not the DA.
So the right.
Or
Sorry,
is it
what
both?
about DA?
Does finalization leak only apply to like the sub protocol that's applying finality, or does it influence the dynamically available sub protocol?
Oh, I see. Okay, so the way the inactivity leak works, right, is that when finalization stops, the chain detects that finalization stops, because the chain itself like regularly collects evidence of like who has been participating, and so it knows if it's finalized. And then if finalization stops, then the chain starts applying progressively heavier penalties to validators who are not participating. And then eventually, yeah, you get to the point where those penalties just keep accumulating, that the people that are still online go up to making up 2/3 of the total balance. And then at that point, the chain finalizes again.
I think we should just adopt that exactly as is. I agree with Dark. I think that the Zcash protocol designers have a little bit of a not invented here tendency. And so the nice thing about Crosslink is that it like FFG, the finalization rule and the underlying chain and the fork choice rule are independent. I mean, I think they're not quite independent in FFG. There's a paper on that. But I don't know whether that applies to a previous version of FFG. There's nothing that paper. But yeah, you can completely just import that mechanism wholesale from Ethereum as closely as possible, and it works fine with Crosslink. And you can also change, so after the transition to Crosslink, you can then change how the what's now the proof of work protocol works. And it's a little bit safer to do that then, because you already have the finality rule. So there are only so many ways you can mess up.
Okay, let's hear from Henry, then Christopher.
Sure. Okay. So this, I'll just caveat with like, this is like, you know, just like my opinion, man. I agree
That's why we're
that
here.
Zcash should like take a consensus mechanism from like just sort of off the shelf. The thing that I would flag as like a very important concern that hasn't been discussed so far is light clients and their implications for interop. And like with Ethereum, there's not really a like economically secure light client in the same way that there is for Tendermint, like at this instant, as far as I'm aware. And that's kind of like more fine because Ethereum is sort of like already at the center. So like if you're doing an L2, it's like an L2 of Ethereum. But right now, I think that there is kind of an existential problem for Zcash of how do people actually use it? How does Zcash connect to other stuff? And I think that it is like most important to be able to provide an answer for how a proof of stake version of Zcash can do permissionless interop with other systems. And I would go so far as to say that like Zcash should like contort itself into a shape that some other chain already knows how to deal with specifically for that purpose. Like I think the win of having that interop is sufficient to make that trade-off justified. And we did that for Penumbra. And if people don't agree, then they can not agree, and that's like fine. This is just like my opinion.
I have an opinion on that.
I want to hear
Me first,
from
or
Christopher.
okay.
Yeah, because let's cycle around a little bit more.
I'll keep it quick. Just a note, and it's related to interoperability, is that you mentioned, Nate, a desire to avoid validators going to a private Discord chat as a method of restarting the chain, and potentially a hybrid protocol as an advantage in this regard compared to a pure BFT protocol. While I share that goal, I wanted to note that I think actually obtaining that advantage from the hybrid protocol in practice is dependent not only on the design of the hybrid protocol, but also on how it is that other people choose to verify finality. And if, maybe if you have this kind of inactivity penalty and eventually you change, if you entangle the finality gadget and the block production, which can proceed independent of finality, maybe you have more ability to recover from this without some kind of extra protocol social coordination, but that would definitely require a very different light client, right? So there's maybe a bit of an axis of incompatibility here, at least in the short term, where you might need to make some choices. If you just have if you have a hybrid system, but the only way to recover the finality gadget part of the thing is people coordinating, and if people coordinating, if a lot of other chains are using the finality gadget to verify Zcash, or people are using the finality gadget to verify Zcash, then you might not really have avoided the thing that you set out to avoid by pursuing a hybrid protocol instead of a pure BFT one, if that makes sense.
Yeah, that makes sense to me. Vitalik.
Yeah, I mean, so first, I guess on the inactivity leak piece, I mean, I guess I'm struggling to understand like what you mean by like needing social consensus to recover. I mean, or I guess like we need to think about two situations, right? One situation is more than a third go offline. And that's the thing that an activity leak recovers from, and like you need zero social anything to do that. Like the only thing you need is just like network synchrony assumption. And the second piece is like recovering from 51% attack, right? But like there are mathematical theorems that literally tell you that there cannot be purely computational and non-social ways of recovering from a 51% attack, right? So there are definitely like things we can do to try to really approach that, right? But like there are also fundamental limits we have to work around, and that's true in any system. Yeah, Chris, what?
Absolutely. No, the thing I mean is just specifically that for this to work, for the goal, which I understood Nate articulating, the light clients of Zcash have to implement the inactivity link correctly. And that's the part that I think that is doable, but hard, and may come with time trade-offs that are unfortunate.
So I don't think it's hard. I mean, okay, so I guess I can speak to the like Ethereum side of light client design, right? So currently things like Ethereum light clients depend on a sync committee, which of course is not economically secure. And the reason why that was done is basically because the number of validators is just too large, and the committee mechanism in particular is just too like like it's too large for data-wise for like clients to like actually be able to constantly interpret all the different committees. So first of all, if you go to a design where you get rid of the committees and you have a smaller number of validators and you basically lean more on like decentralized stake pooling to keep the decentralization, then you don't have this problem at all, right? And then the design that works is basically like you don't need the sync committee. I mean, potentially, if it's light enough, a light client could just like evaluate the consensus directly. The highest overhead is basically like whatever your validator count is. It's that number of signatures per slot, and like because like basically everything aside from that is just bookkeeping, right? Like the fork choice rule was just bookkeeping, and bookkeeping is very cheap. Like doing even huge amounts of bookkeeping is cheap relative to verifying one signature. And so the other thing that we can do is you can put a ZK snark over signatures, right? So you have some set of actors where basically, yeah, they just like wrap sets of signatures that they see in proofs, and you just have this object that's like, here's a bit field, here's a snark showing that the bit field is correct, and then you just like, as a client, you see these and you take the union of them, right? And then that gives you a light client that both of the finalizing part and of the available chain part. The hardest part of, I think, yeah, doing this in practice is just like, I mean, so one, like it's like this approach is not that feasible in status quo Ethereum because there's just so many validators and it does rely on committees, right? And so one of the things that we're currently thinking about is like, what would the long-term design look like? And like, that's one path. There's also some other paths. And then the other thing is you just have to make sure that all of the substrate that you're using just is like Snark prover friendly or otherwise aggregation friendly, right? So like with BLS aggregation, like you can do everything fine, and like you can probably verify like 4,000 signatures a slot just inside of a MetaMask or an equivalent. But I mean, we're also looking at quantum proof, and then for quantum proof, like so far, the most viable thing looks like Starks over hash-based signatures. So like, yeah, you have to get the aggregation piece right, but like if you do, it's totally verifiable inside of a very light client.
Just a technical point. So if you have a post-quantum ZK proof system, why do you need hash-based signatures? Because it's trivial to just check that someone knows pre-image of a hash. That is a signature scheme.
Okay, yeah. So yes. Right. Okay. So the thing, like the one challenge, right, is that you have n different actors, and each of those n actors are privately making some kind of like basically proof tied to the latest message that they own the key, right? Because that's what a signature is. And then you want to have one step at the end, where the one step at the end is like just for scalability, for aggregation, right? Because you want everyone after that point to only have to verify one proof instead of like 4,000 things. So because the first like layer of that involves private information, like you inherently need those two layers, right? It's like the first one is done like on the edge for privacy, and then the second, security.
Yeah, I mean that's what we're thinking of doing anyway for transactions. Actually, my post-quantum Zcash talk mentioned that technique. What was I going to say? So there's the just throw ZK stocks the problem thing, which I think could actually work. So I'm gonna sort of go out on a limb here and say that I think smoke-filled rooms are not that bad, because there are some things that they're necessary for. So if you have a critical security bug, I think so something like the Bitcoin overflow bug. People had to sort of be in a smoke-filled chat room and decide what was going to happen, decide which chain was the new chain. And that I think there is always the possibility that that situation will happen, and sort of a group of trusted people are going to have to decide what happens. But so a group of trusted people is writing the consensus nodes anyway. So that kind of centralization is very difficult to avoid. you can have more consensus nodes. For the time being, we're only going to have Zebra. So we don't have the option to sort of have multiple independent node implementations, because we're deprecating Zcash D, which we absolutely need to do. And so that kind of centralization exists already. For the time being, we should just learn to live with it.
All right, I wanted to take things in a new direction, but first I wanted to check in with Henry.
Oh, I was gonna just a tiny add-on to Dara's point about the smoke-filled rooms. It's like, I think it's good for people not to be like regularly, you know, in the room. Like maybe there's some kind of crisis. At the point that there's a crisis, it's like, okay, Avengers team assemble, like, let's figure out how to deal with this. And you do want that, because if there were a crisis, you want to be able to respond. But it's important that that not be kind of part of the like normal functioning of the system. And I think that that's a useful frame, right?
Yeah,
Totally agreed.
the let me see. Yeah, my thinking about it is basically as long as any faction can coordinate well enough on doing their own chain split or hard fork, that's good enough. So I guess nothing prevents two different groups from, you know, like agreeing on which BFT reboot parameters they want. So maybe that's okay. The other direction I wanted to go is we've touched on it a little bit, but like basically, this is an area I don't know that much about, but financialization, derivatives, and things like that, and how they influence protocols and governance and so forth. So like one thing I've been wanting to learn more about was the emergence of Lido and the impact of Lido, like uh, uh, and also just generally for derivatives, is that like, how can I think about the fact that derivatives can just emerge all the time by centralized players and people seem to like them for a lot of reasons? How can we make protocols resilient to that reality? Any thoughts or stories?
I guess my maybe slightly contrarian take is that in a certain fundamental way, you can't. This is the beauty and terror of permissionless systems, is that there's never a boundary that you can draw around a set of participants and actors and protocols and say the only things that we need to reason about are the things within that boundary. Well, of course, you do that in practice. That's what protocol design and reasoning about incentives means. It requires drawing a boundary, but the boundary you draw will always be wrong, because there will always be other things going on and other incentives and, you know, many things beyond just liquid staking tokens, bribery, or things happening on other chains. You know, no one really, there was this whole concern when smart contract chains launched that people would build bribery smart contracts that would bribe like the other, you know, other chains as soon as there were like clients to sign particular blocks. For the most part, this didn't happen, at least as far as I know. But it still could. And, you know, I think many certain tests of geopolitical resilience still haven't happened yet. So there's a lot to be seen. On the other hand, I think one can also look practically at market structures, including of existing liquid staking tokens or other kinds of financialization, and assess risk maybe more pragmatically on that basis. You know, I can't speak as to the Ethereum case, but in Cosmos, there are a few liquid staking tokens. I think the most prominent one is Stride. Penumbra, of course, has a certain kind of LST built into the protocol. Henry could talk us to that. On the whole, my personal opinion is that in Cosmos, their impact has been very minimal, both good or bad. I think it's just been minimal. It's like having one extra node in the principal agent chain, and you know, maybe that node actually adds some diversity in picking validators, and that's kind of good. They take a little bit of fees. there isn't enough. I mean, frankly, in Cosmos, there just wasn't enough capital to like encourage a really large ecosystem of financialization. I don't know what Zcash's case may look like, but there may be some lessons you can draw there.
Cool. I just wanted to like call out some papers I have run across, but I haven't understood yet by Tarun Chitra. And let me hunt for a name, but this was around the time that this is shortly, I think maybe after the Luna collapse, where I became really interested in this. And I think Tarun Chitra had a paper about if you have a proof of stake system, but there's this amazing, really high yield opportunity that's an alternative to staking. How would that play out? And I think the I think he was doing some sort of like agent simulation thing that I didn't quite understand. But I feel anxious that practically lots of people will make poor decisions, and those can add up to problems that are systemic. And and also hearkening back to the beginning of this conversation where people suggested not to rely so much on direct financial incentives. I feel like that makes sense right now for the scale that crypto is at, but I'm a bit anxious that if it like expands to a larger and larger scale, those kinds of issues become more and more important. So just
Is that paper competitive equilibrium between staking and on-chain lending by Tarun Chitra?
yes, that is.
Okay, cool. I will read it.
I was just searching for it this morning, and I found a different one that also seems fascinating called Why Stake When You Can Borrow? And it's about these sort of principal agent problems. But yeah, Zuko.
Okay, three quick things that are each very short. One is go read this really old paper by Joe Bono with a similar title called Why Buy When You Can Rent, which kind of, to exaggerate, it kind of shows that both proof of stake and proof of work are both insecure. And my second point is this whole conversation is sort of the other side of what we talked about at the beginning, where we said there's principal agent problems in slashing. And I think we concluded what I like, which is that doesn't matter. You slash the principal, and it's the principal's problem to manage their agents. And this is the opposite of that, where who are we rewarding? Does the same solution apply? I don't know. We're going to skip on to the third thing. The third thing is, yeah, I don't really trust that proof of stake is secure. I'm a little bit further along because Ethereum is doing so well. And I don't really trust that proof of work is secure. I'm like, 60% along because Bitcoin survived 15 years, but that's not enough for me. So I really like hyper proof of work, proof of stake, because I don't believe in anything by itself or anything at all. That's all.
One comment just on the Terra thing. I think that's actually quite an interesting case to study, the Terra collapse, I mean, because as far as I can tell, things basically like went fine. Like aside from the fact that the whole like ecosystem collapsed to zero or whatever, like yes, like all of the
The
I don't
humans
know
were
what the right
hurt,
metaphor is,
but the machine.
the
But
city is
the
like
protocol works.
collapsing, but like the streets stay clear or something. The consensus mechanism of the chain kept working, and the IBC connections like also still functioned. And I think that there was some amount of like, the Avengers team assembling I wasn't part of it, so I don't actually know. I think that some people did step in to try to make sure that things went smoothly during the collapse, but we didn't see a kind of like total failure of the consensus mechanism in that instance. And I think that speaks to a point that has come up a few times, but was discussed by Chris of like, it turns out that a lot of people running parts of this infrastructure are actually doing so for a complex set of personal reasons, which are not all reducible to just like a number go up, right? You could ask the question, for instance, today, like, why are there any Zcash nodes? Right? There is no like direct economic incentive to run a Zcash node, and people do it. And I think that that is evidence that that there is kind of something greater out there. And so to Zuko's point about, I don't know if I trust like proof of stake, I don't know if I fully trust proof of work. If I'm sort of imagining this like sort of like idealized like spherical cow model of proof of stake, where there's just these like spherical cows that are perfectly responsive to incentives, I don't know if it works, but it seems like a lot better than nothing, even in that model. And it feels like a very solid baseline where ideally all the people who are participating in the system, or a majority of them, have some other sort of basically aligned interest, but you have this kind of bedrock or baseline foundational system that says like, look, there's this base set of incentives, and that selects for people who have their own incentives that are kind of compatible with the ostensible incentives of the system. And I think that's actually the true kind of interplay of the consensus layer and the social layer. And the reason why there's this kind of like extra security budget for all of the proof of stake systems that have been deployed, whether it's kind of at the far end of the sort of robustness spectrum, which I would say Ethereum is, or even on like, small, tiny Cosmos chains, where what is the actual economic security? I don't know. There is some additional security budget, and it's hard to precisely quantify it, but it's definitely not zero.
The Avengers budget.
Great point, Henry.
Yeah, I think altruism shouldn't be underestimated. I mean, yeah, we live in a society, and people care about more things than money.
All right.
Oh, yeah.
So
if I could be indulged for, I do have one follow-on point to the altruism thing, which is it is also beneficial to not try to select participants purely based on financial incentives. And one thing that has gone well for Penumbra is that the chain didn't choose the kind of we'll just get like people to come in and have like a super high staking rate or whatever, and that meant that the people who showed up to run nodes at the beginning of the network are people who are actually aligned with the project, and that's a super powerful foundation, and Zcash has an enormous amount of goodwill, and it should leverage.
Definitely.
Yes.
So let's see. I've only seen one listener question fly by. Did anyone notice others?
There are several questions on the chat. Are you seeing all of them? Because I noticed the previous speaker wasn't seeing all of the questions that had been posted.
Yeah, I'm having a little bit of trouble with the chat.
Okay. Well, I can read the questions from Hoover. Okay. Let me figure out which ones have already been answered. See, how can we ensure that staking requirements promote as much economic decentralization as possible? So it's not to structure it in a way to preclude the participation of Zcashers from less affluent countries who potentially hold only relatively small quantities of ZEC. So delegation is obviously relevant there. I think what Penumbra is doing with private delegation is necessary, but it probably also isn't sufficient, maybe.
Yeah, anyone else want to comment? I agree that delegation is a big piece of that, like offering a way for non-specialists or low, folks with less capital to still participate.
One idea that is not implemented, but has been posted to the forums, and if there's interest, could potentially be implemented, is the idea of having a kind of like stake boost, or like almost like a sort of lottery system that would provide a differential benefit to smaller validators, but with kind of incentive structure that's set up so that if you're a large validator, your marginal benefit to like splitting your stake in half and sibling is so small that like it's probably not worth the hassle. But on the other hand, if you are like a tiny value, or if you're considering it, the expected value of being a more active participant is has some improvement. And I think there's interesting avenues like that, but it's tricky to make sure that you're getting the incentives right and not just like making something that people can game.
Where can I read more about that?
There's a Penumbra forum post.
Cool.
It's called Stake Boost. If you search that on the forum, it should show up.
Thanks.
Okay, here's another very Zcash specific one. People are curious about a timeline for the transition. One thing I could share is Shielded Labs is focused on this hybrid consensus protocol and deploying it. That's called Crosslink, and that's the first step. And we're publishing a blog post with a timeline, hopefully this week, like maybe tomorrow, but definitely by next week. So stay tuned for that. I think the punchline is basically, I'm not too clear on if we have a system that's totally working on a test net and has all the features, and its design has been reviewed and the code is audited. How long does it take to get from there to having something activate on Zcash? I'm not quite up to date on the.
Yeah, it has been an issue to kind of get consensus changes past the finish line, as there's a long lead time. And there are things that we could do to improve that, maybe from the technical side. But there's also a lot of social organization associated with an upgrade. I was sort of complaining just before we started that I'm concerned that the set of features for NU7 has still not been completely nailed down yet. I expected that to happen in January, to be honest. I don't know why it hasn't happened, because there were a set of fairly clear recommendations from the zip editors, and there didn't seem to be that much disagreement with them, and yet we're still up in the air. So I think some of the social processes around network upgrades need to be streamlined. But yeah, politics will be politics.
Right. Okay, so I guess I could share the punchline from the blog is that Shielded Labs plans to like do all of the work to make a working implementation that we can do without blocking on external Zcash developers. So we think we can have a working implementation in about 12 months. And then however long it would take to go from there to activation is more uncertain. And it's also something I think we can continue to improve upon as across the orgs as we approach that. Yeah. Well, I wanted to thank everyone for showing up. It's been really helpful for me, hopefully helpful for the audience, and I really appreciate hearing from all of you.
I think this was my favorite panel I've ever been on.
Yeah.
It's a great panel.
Thank you.
Especially because I'm not in a poofy chair on a stage. That's a chair that's too poofy. They're always too poofy for me.
I hope I didn't hug the mic. too much. I have a little bit of tendency to do that sometimes.
Thank you all so much.
Great. Yeah, this was a lot of
It's
fun.
so
Thank
helpful.
you.
Thank you.
Thanks
Bye.
all.
I'm really
Cheers.
excited about everything you are all building also.
Yeah, me too.
It's,
Keep it up.
it's great to talk to a bunch of smart people. I love my job.